Hello, my name is GDaviduk, and this is my presentation on the periodic table. So a little bit on the history of the periodic table is that in 1669, the German merchant and amateur alchemist Henrik Brand was attempting to create a philosopher's stone, which was an object that could turn other metals into pure gold. It's highly sought after because gold was extremely valuable during this time period. And he went through these testing phases in order to create the stone, in which he heated residues from boiled urine, and a liquid dropped out and burst into flames. And this was the first discovery of phosphorus. And then in 1680, Robert Boyle also discovered phosphorus. It became public. This was the official discovery of phosphorus. And in 1809, 47 elements were discovered, and scientists began to see patterns in their characteristics. In 1863, the English chemist John Newland divided the then discovered 56 elements into 11 groups based on their characteristics. As you can see here, this is the Newland's arranged elements in octaves, and these were sorted by their relative atomic mass. And the pattern shown by each of these elements was that each element had similar properties to the element that was 8 places ahead of it, meaning that lithium was 8 places behind hydrogen, but had similar properties into it. So he noticed these patterns and he started grouping them in this way in order to better organize these elements. And then in 1869, the Russian chemist Dmitry Mendeleev discovered or started the development of the periodic table. And he did this by arranging chemical elements by atomic mass like he did before. However, he predicted the discovery of other elements and left spaces open in his periodic table for them to basically be filled in as they've been discovered. And as chemists found later on, Mendeleev's predictions of these other elements were correct, and these spaces were filled later on with their discovery. And they did share the same properties that he predicted by the grouping. And then in 1894, Sir William Ramsay and Lord Rayleigh discovered noble gases, and then they added it to the periodic table as group 0. And as you can see here, this is the next rendition of the periodic table, the 1894 rendition. And it's pretty similar to Mendeleev's periodic table, except that with the addition of the noble gases. And as you can see here, there are some spaces left open because these are the places where Mendeleev basically predicted that there would be other elements that would be discovered. And then in 1945, this is the last rendition of the periodic table and the most similar to the one that we have today. Glenn Seaborg identified lanthanides and actinides, which have the atomic number which is greater than 92. And these are placed below the periodic table usually. And as you can see, this is the most similar to the modern periodic table that we have today. And you can also see that there have been spaces that have been filled because of the elements that Mendeleev did predict to exist, but didn't have definite proof during the time when he created it. You can see that these spots that were left open are starting to become more filled because he was able to predict it. So why does organization matter? The periodic table is organized in an ingenious way, which allows trends such as ionization energy, electronegativity, atomic radius, and electron affinity to have patterns that don't really fluctuate and are basically set in stone on the table itself, making it very easy for students to learn. And I will be breaking down what each word or symbol means on the on each element for on the periodic table. So as you can see, the top left number, the atomic number, is the number of protons in the nucleus of an atom. And then this determines the chemical properties of said atom and is placed on the periodic table. For example, gold has 79 protons, so its atomic number is 79. And then the chemical name is very self-explanatory. It is just the name of the element. but the chemical symbol, which is the harder part to identify, basically is the abbreviation of the element's name. You will see that the first letter is always capitalized and the following letters will always be lowercase. And then finally, the number at the bottom is the average atomic mass, which is the mass of the atom of all the masses of the natural occurring isotopes of that element. And you can see this through mass spectrometry, which you will do later in the year, where a single element has different isotopes that each contain different atomic masses. And then they average it based on how often it's occurring in the natural world and the weight itself. And they create the average atomic mass, as you can see here. And then lastly, the periodic table has grouping systems which allow for the alkaline metals, alkaline earth metals, the transition metals, the other metals, the semi-metals, the halogens, the noble gases, and the other non-metals to be organized. And this was done in a very unique manner, as they are able to be displayed next to each other, showing that there is a lot of thought and organization that goes into the periodic table. So next time you look at the periodic table, you should be appreciative that they organize it in such a way that makes it easy for chemistry students like us in today's time to understand these patterns and understand the organization of each of these elements and basically be able to apply that to today's world. And that concludes the presentation. So thank you so much.